Hi there, I'm Scott Lowe with ActualTech Media, and thank you for joining us for this Spotlight Series video. I'm joined today by Noemi Greyzdorf, who's the Vice President of Marketing for Vcinity. Noemi, thank you for joining us.
Oh, my pleasure. Thanks for having me, Scott.
So can you kind of give us the 30,000-foot overview of who you are and who Vcinity is?
Sure. So as you mentioned, I'm the VP of Marketing. I've actually recently joined Vcinity, been in the storage industry, and what captured my imagination is the capability and what Vcinity really enables folks to do, enterprise to do. So what we call the connected enterprise. But the gist of it is as the data gets created in a very distributed, geographically distributed sort of environment. We have the edge compute, we have the cloud, we have IoT devices, we have video surveillance data, we have just imaging. There's just a lot of data that is created in various locations, and at the same time, we're trying to leverage new technology and new tools available in our cloud, where we can, take advantage of elasticity or newer approaches, tools. And the challenge has always been, hey, the data is here, my compute is here. How do I bring them together? And traditionally, we made the assumption that you can't do anything, right? You have to have them collocated. So we've looked to solutions that can move the data faster, they can store it locally, they can create multiple copies in order to have them cached or stored local to where the application, right? So what attracted me to Vcinity and why I joined is that with Vcinity as technology, you're now able to eliminate the time lag required to do that, to move data around, to figure out how to do it in a safe, secure sort of way. We're actually enabling organizations and applications to deploy their compute resources wherever it makes most sense, and to access and process data wherever that data is, without having to move the data at all. So we're reducing the time to insights and time to value. And when I learned about it through a friend actually, and started thinking about it, the use cases and the applications are just they're just everywhere. So that's what kind of brought me to it.
What it sounds like is Vcinity is trying to help organizations capitalize on recency of data. Stale data is worse than no data in a lot of cases. And you're doing that, and we'll get to the magic solution, the magic in just a second, by making sure that applications can access that data more quickly, and as you mentioned, quicker time to value, quicker insights using recent data. So I have to ask the million-dollar question, which is how? How does the magic happen?
So what initially was a government-sponsored project has evolved into what we call the Vcinity Data Access Platform. And what it is, it takes the standard RDMA protocol, which is traditionally deployed inside the data center. It's a low latency protocol. Think of InfiniBand most commonly. There's another, Rocky is also another very common RDMA, and we encapsulate it in our own patents, in our own technology. This is where the special sauce comes from. And then we give it an IP address, and we're able to, and that's the whole point of data access, right? We can have that data access over a WAN link, over high latency, long distance connections. And it doesn't have to be, terrestrial. It can be a 5G, it can be satellite, it can be pretty much any WAN man kind of environment. We don't care. We just need the data handed to us in our DMA. We encapsulate it. We make it accessible. It's a bookend approach, so you need us on both ends. And then your experiences, whether you're accessing the data in real time, which is where you feel like you're actually sitting on a LAN with typical LAN latencies, or if you really need to move the data for some reason, then you're moving data pretty much at line speed.
So what you mentioned, lots of different types of connectivity, especially when we have these sprawling organizations that have, especially when you think about mobile, like cruise ships or oil rigs, or shipping
Absolutely.
contains shipping vessels and things like that. Those are incredibly data intensive organizations. So you're helping them. Regardless, I mean, satellite's not known for being exactly super speedy and super non-latent. So you're helping them do better and get more accurate information from the data that they're capturing with whatever they're doing out in those remote locations as well.
Yeah, so just give you an example. We have a test that we just ran literally Thursday, Friday last week, and it was a 500 megabit satellite link, 500 millisecond latency. And now we don't eliminate latency. We can't do, I haven't figured
Right.
out what the
Physics
time
is
warp.
still physics.
Yeah, physics is still, that's right. But what we do is we eliminate the intermittency of latency, right? So once you experience that first byte of latency, beyond that, it's as though the data is local. And so how do we achieve that? So on this 500 megabit connection, 500 millisecond latency, we actually saw data transfer in this case, and it was offshore entity to onshore facility. We saw them transferring rates at 490 megabits per second. So that's pretty much line speed.
Yeah. And that's, I mean, you don't always see that. What are you encapsulating? It sounds like you're encapsulating the data. This is not a protocol extension sort of thing. When you were first describing this to me, what sort of jumped to mind was iSCSI, but there you're sort of encapsulating a bunch of storage commands you're sending off to a storage array. The data is not moving. You're doing something a little bit different. What are you encapsulating? Is it actual data that you're then bringing, or what's happening there?
Right. So today we work with unstructured data only, and we do need somebody to hand us the data in RDM as an RDMA, right? So, for example, we leverage parallel file systems such as IBM Spectrum Scale or GPFS, Luster. We're working with a number of other vendors to qualify and make sure that we're all interoperable and everybody's copacetic. But today, if you were to deploy a spectrum scale on one location and a client or a spectrum scale instance on another location, they would hand us off our data in RDMA. We would do our magic and then hand it off back to spectrum scale, who can then communicate to whomever over TCP, which is the traditional sort of local protocol. So that's an example of how we would sit. Right.
It sounds to me like when you were describing how this works, it's not like the data is just randomly spit down to some other location. When we were talking before, one of the things you mentioned was you can kind of look into the data to make sure that the right bytes that are necessary are being brought forward first. Can you kind of give me a description of how that works a little bit?
So it's the application that is mounting, it sees an NFS or an SMB mount point, for example, right? And it's accessing the data just like it would typically over a NAS. And then we're doing all the magic in between.
Very good. So if I were, if I were someone looking at this, what are the most common use cases that you're seeing? I know you mentioned this a little bit, but what are some specific use cases you've seen customers actually using the product, and what kind of benefits are they seeing?
Sure. So some of the examples can be sort of data analytics, physical security, right? Because now you're able to process data in real time, which is kind of the new currency, right? The time is, what is it they say? Time is money. And in this case, time is money. So physical security is one aspect of it, obviously. If you mentioned offshore rigs and cruise ships, but think of airplanes, for example, being able to in real time monitor what's happening, what metrics and logs are being generated by an airplane as it's flying, and if there's any kind of issues, you can address them in real time. Again, you can provide some feedback. Other use case in media entertainment, video rendering is a very common use case. Many folks are looking to leverage compute in the cloud to do that. We know some use cases in e-discovery and litigation support, because moving data can be dangerous. There's cyber security concerns, there's insurance policies that have to be taken out if you're moving a lot of data. So being able to just reach in and process it and analyze it in place is, there's significant amount of value in that. HPC environments where we actually enable InfiniBand fabrics to connect to clients on Ethernet without having to move, copy, or do anything with the data. And I was listening to actually the opening remarks at the NVIDIA GTC 21, the keynote. And, many of the examples that he was talking about where we're seeing, GPUs and being used to accelerate our discovery, whether it's drug discovery or something else. I think that if you think about all the data that is being created at the edge, whether it's IoT devices, cameras, images, healthcare, government, oil and gas, energy in general, telecommunications. In all of those scenarios, the faster you can access the data without having to move it, and the complexity associated with moving it, the more value you're going to get. So you're going to get the cost benefit, but you're also going to get the upside, revenue generation, differentiation opportunity.
Very good, Noemi. Thank you so much for your time and helping us understand what Vcinity is bringing to the table.
I'm excited. Thank you, Scott.
And for our audience, if you'd like to learn more about Vcinity, please visit vcinity.io. And thank you, as always, for watching this Spotlight Series video.